Hey, all right, so we are now going to try a slightly more complicated problem. This more complicated problem is sort of like, I don't know, if I were to look at this, I definitely feel like an eighth grader should be able to do this in algebra. Well, an algebra student should be able to do this in algebra. I shouldn't say eighth grader because I expect like a ninth grader to do it or 10th grader to do it. But I expect you to be able to handle this level of problem for sure. I also expect you to be able to handle the next level of problem for sure. But this particular problem requires us to actually do step one. It's not actually just given to us. So we have the system x plus 4y equals 6 and x plus y equals 3. Okay, basic enough. But looking at this, these are in standard form. They're not solved for a single variable. That means I can't set them equal to each other. I can't get one of the variables to disappear or anything. I need to actually do some work. So step one, I need to solve for the variable in at least one of these two equations. It doesn't matter which. And honestly, if I look at them, I could even solve them both. But the whole goal is to at least get one variable in one of these equations to be by itself. I'm going to pick this top one, mainly because this 4y bugs me a little bit, and I'm going to solve for x. So I'm going to get the x all by itself. And to do that, I'd have to subtract 4y from both sides. So I'm going to have x is equal to 6 minus 4y. Cool. So I've gotten one equation solved for x. I can easily do that here with this equation. However, yeah, I'm going to just do it. So I'm going to subtract y from both sides. So I get x is equal to 3 minus y. And so now we have them both set up in the same way. They're both solved for x. Last time we solved them for both for y. This time they're both solved for x. So now I can do step number 2. I can substitute one of these equations, x is equal to 6x minus 4y, in for x in this other one, and I can create one solid equation. So I get 6 minus 4y is equal to 3 minus y. And now let's solve for y. Let's get y by itself. So I'm going to add 4y to both sides so I can get positive y values, just because that makes my life a little bit easier. So negative 4y plus 4y, that equals 0 y's, which I can say is negligible. I can just look at the 6 now. I get 3 over here, and negative y plus 4y equals positive 3y. I'm going to subtract 3 on both sides. I get 3 is equal to 3y, divide by 3, divide by 3. I get 1 is equal to y. So if I had my start of my ordered pair going, I could say 1 for my y value, for my ordered pair. I'm now going to put this into one of these two original equations. I'm not going to put it in my manipulated equations, these ones over here. Why? Because I don't know if I potentially made a mistake. Now, knowing that I made sound moves, I could potentially put them here, but I always suggest you go back all the way to the original equation, just so that way you don't potentially make, just in case something did go wrong here that you didn't realize. I'm going to use this second equation because it's a little less complicated. So I'm going to put this 1 for y into this equation here, and I have no room to do that now. So sorry. We're going to erase some of this so I can actually do this. So I have x plus 1 is equal to 3. So instead of writing y, I wrote our 1 because we know y is equal to 3 now. Can subtract 1 from both sides, and I get x is equal to 2. So that means my ordered pair 2, 1 is apparently the solution to this. Now I should check my work. If I put 2 plus 1 in here, so 2 plus 1, the x plus the y, I get 3, and 3 is equal to 3. Awesome. I'm going to put 2 in here, so I have 2 for this x. 2 plus 4 times 1, so 2 plus 4 is equal to 6, which is also a true statement. So this solution here, this ordered pair, is a solution to this systems of equations. Cool, yeah? I'm going to have one more slightly complicated problem that I want you to be able to do as well. So watch this next video, and then after that, you can start working on the must-do practice problems. Thank you, as always, for watching.